Good morning, teachers. Our topic for today is something very related to our professional practice as science teachers. This lecture is about teaching science through inquiry, and I do hope you get to learn what inquiry is all about and what inquiry is not in this short lecture. So for starters, let's try to evaluate the following statements. If you find the statement to be incorrect, label it as a misconception. If it is correct, label it as a fact. So let's have the following statements. Inquiry-based instruction is all about the application of the scientific method. Okay, so think about the statement first, if it is a fact or a misconception. Are you ready? Okay, so it is a misconception. Let's go to the next statement. Inquiry-based instruction must make students generate and pursue their own questions. Okay, think about it for a while. Are you ready? Okay, so it is also a misconception. Let's go to the next statement. As long as there are hands-on activity in the class, there is inquiry-based learning. Think about it for a while and see if you are correct. Are you ready? Okay, so it is also a misconception. Let's go to the next statement. Evidence is important when doing inquiry. So think about it for a while. Are you ready? Okay, so it is a fact. Let's go to the next statement. Inquiry is only for high-achieving students. What do you think? Are you ready? Yes, it is a misconception. So what exactly is inquiry? According to the U.S. National Research Council, which drafted the National Science Education Standards, scientific inquiry refers to the diverse ways in which scientists study the natural world and propose explanations based on the evidence derived from their work. Inquiry also refers to the activities of students in which they develop knowledge and understanding of scientific ideas, as well as an understanding of how scientists study the natural world. In inquiry, the students usually demonstrate certain science process skills. These are the basic science process skills like observing, inferring, measuring, communicating, classifying, and predicting. There are also integrated science process skills like controlling variables, defining operationally, formulating hypotheses, interpreting data, and experimenting. These skills are usually manifested on the essential features of inquiry set by the U.S. National Research Council. These essential features are given in 5 statements that describe what learners are doing in an inquiry-based learning environment. They are: learner engages in scientifically oriented questions. Learner gives priority to evidence. Learner formulates explanations from evidence. Learner evaluates their explanations in light of alternative explanations, particularly those reflecting scientific understanding. And finally, learners communicate and justify their proposed explanations. Let's go to the first statement. Learner engages in scientifically oriented questions. These are scientifically oriented questions. questions about objects, organisms, events in the natural world, and are connected to science concepts. These are questions that can be answered by doing an empirical investigation, gathering data, or using data for explaining scientific phenomena. So these are some examples of scientifically oriented questions. Why does the wind blow? How do we breathe? How does light help us see things? Does air have weight? The next essential feature is learner gives priority to evidence. Some of the evidence needed in a science lesson may be the appearance of germinating seeds, listening to sounds produced by different objects, observing the path of light passing through a glass, or even observing the sky. If you are going to teach a lesson about sounds, for example, you start first with the observable. Some examples are identifying the object based on the sound produced, comparing the pitch of the sound, relating the loudness of sound based on the distance of the source from the listener, or investigating how loudness and pitch of sound can be changed. The next essential feature is learner formulates explanations based on evidence. You can see here the table, and the table shows that when the length of the string of the pendulum is shortened, it swings faster. The question shown below makes the learner derive his explanations from the evidence that came from the data in the table. The next essential feature of inquiry is learner evaluates his explanations in light of alternative explanations, particularly those reflecting scientific understanding. So a situation was presented in the lesson. Mang Ambo wants to find a storage bin to store mango seeds that he intends to sell in the market. After finding a large bin, he washed it with water and placed the mango seeds inside. Did he do the right thing? Explain your answer. So the situation presented in this lesson allows the learner to apply the concept that water is needed to start seed germination. After they have learned that water is needed to start the germination of seeds, a situation is given so that he will form his explanations based on a current scientific understanding he learned from a previous lesson. The next essential feature of inquiry is learner communicates and justifies his explanations. The activity made the learners listen to a familiar sound and they draw the place where they usually hear the sound. In this case, they observe by listening to an audio tape. Then, they inferred that it is heard in church. Finally, they started drawing what they inferred. This is actually a tryout in a public school. In an actual tryout of an inquiry-based lesson on sounds, we can identify features of inquiry embedded in the tasks or questions in the activities. For instance, the question, how can one bottle produce a higher pitch sound than the other when struck with a spoon on the side, shows that the learner engages in a scientifically oriented question. When the learner is asked to explain how he can change the pitch in the two bottles, the lesson makes the learner give priority to evidence and formulate explanation from evidence as the learner tries to change the amount of water and tests if the pitch of the two bottles are different. When he explains that changing the amount of water will make one bottle produce a higher pitch than the other, he is forming an explanation based on evidence. In this next activity, the learner is asked to arrange the bottles in order of increasing pitch of the sound when struck by a spoon. The task where they are asked to arrange them makes them use their previous understanding that lessening the amount of water will make the pitch of the sound higher when tapped at the middle with a spoon. As the learner is asked to explain why he arranged the bottles in that manner, the essential feature of inquiry that manifested is the fourth one. Learner evaluates his explanations in light of alternative explanations, particularly those that reflect scientific understanding. Since the learner is asked to draw his setup and tests the sound of each bottle by tapping the side with a spoon, he also demonstrated the fifth essential feature. Learner communicates and justifies his explanations. This is an example of the actual tryout done in a public elementary school. Take note that the actual tryout was done in the lowest section where most of the students are low achievers or slow learners. So the question now is, was there learning after that inquiry-based lesson was conducted in this section? A pre-test and a post-test were administered in this class where this implementation of the lesson was done. And the results showed that the mean difference was statistically significant. That means a significant learning outcome took place despite of the pupils' inadequacy in science process skills. So what were the realizations from the tryout? Science process skills must be emphasized more than just memorizing science terms and definitions. Pupils' responses must be studied to see how children think and what science process skills need to be enhanced. Mean difference between the pre-test and post-test scores was significant, implying that learning took place. The inadequacy of science process skills is not an excuse for not teaching inquiry-based science to low-achieving students. One researcher even said if a group of students is exposed to certain types of questions and if their responses are monitored to improve their quality rather than correctness, then they will be able to answer similar types of questions better than a group of students who have not had this exposure. Another realization is the importance of children's drawings. Drawings are powerful tools in unraveling children's thinking, especially for children who have poor communication skills. Piaget recognized also the importance of drawings to understand children's thinking. Let's have another inquiry-based lesson. So on the first question, can mango seeds germinate in soil even if there's no water in it? It demonstrates the first essential feature of inquiry, and that is learner engages in scientifically oriented questions. The task to be done, which is to record the observations in the two setup, is an essential feature of inquiry. Learner gives priority to evidence. When asked what made the seeds start germinating, the learner will be using the evidence from the experiment to explain why setup A has seeds germinating and setup B had none. This is the third essential feature of inquiry. Learner formulates explanations from evidence. Okay, So this time, try to identify the essential feature of inquiry demonstrated in this lesson. For the question, can mango seeds germinate even without soil? What essential feature of inquiry is evident? Are you ready? Yes, learner engages in a scientifically oriented question. After they made the setups and made the predictions as well, the learner is asked to observe the setup for 5 days. Do you know what essential feature of inquiry is demonstrated when they were asked to observe the two setups for 5 days? Are you ready? Yes, learner gives priority to evidence. After looking at the seeds in A and B, what does the experiment tell you? So based on this question, what essential feature of inquiry is being demonstrated? Are you ready? Yes, learner formulates explanations from evidence. And then the learner was asked, support your answer using the setups and the findings. So what essential feature of inquiry is evident here? Are you ready? Okay, learner communicates and justifies his explanation. And for the last part, it says there, if you found a clean container to store mango seeds, what will you check on the container to make sure it will not yet germinate? Why? So what essential feature of inquiry is demonstrated here? Are you ready? Yes, learner evaluates their explanations in light of alternative explanations, particularly those reflecting scientific understanding. So when you are planning an inquiry-based lesson, ask yourself, will this lesson make my students get engaged in a scientifically oriented question, give priority to evidence, formulate explanations based on evidence, evaluate their explanations in light of alternative explanations, particularly those reflecting scientific understanding, communicate and justify their explanations? If your answer is yes, then your lesson is suitable for teaching science through inquiry. So here are our references. Thank you.